Okay, for me, such analogy is Formula One car. So behind such car are engineers, people, crew, mechanics, and lots of data, tons of data. So the same situation occurs for any construction objects. We have an impact of a weather, our car, our preparation of the car depends on how weather impacts on it. So we have also track position. For our construction site, it might be schedule. So how aligned are we with our schedule? Degradation of tires, degradation of mechanical parts, components, accidents, they happen, sorry, but it's the truth. Of course, we try to avoid them as we can, but it's hard. So the digital twin is a way how to help us. Supply chain, so our strategy. Are we going to finish the project according to our assumptions? And all of this data are integrated into one cloud system, and then they may be used by engineers to set the proper strategy. So similar implementation we want to provide with our digital twin. So let's start with the first approach. So digital twin of asset model. So probably we have in that scenario a BIM model containing geometry, components data, some data from construction as it is state, some system ready for data gathering for facility management phase and integrating with our systems, and probably some information about components, for example, in COBI file. And then there is a matter, how do we want to provide this system, this database? It might be relational database, graph database, or any other format. The graph database is great for this task because it's machine readable. And another case which is related to BIMprove project is implementation of digital twin during construction phase. So instead of implementation of digital twin during asset management phase, we want to gather during construction phase as many data as we can and use them to increase the safety on the construction site. Moreover, we can monitor geometry all the time according to our schedule and also validate multiple hazards occurring on construction sites. But also, as in Formula One car, weather has an impact, supply chain has an impact, and of course, safety is the most important factor for us. Okay, so during BIMprove project, we focused to gather survey data, BIM models, historical data, different type of scanners, robots, drones, different type of vehicles, pre-process them, and then use different outputs to provide a safety on construction site for a few use cases, which I'll discuss right now. So two use cases which were chosen for this assignment is fire safety and fall from height. The fire is because we can store some flammable products in uncontrolled areas. And because of that, we don't have sufficient control about environment in which it's stored and fire may occur. Also, sometimes we perform heat-related tasks like welding in the last hours of our working day, and then fire may occur after hours. Sorry. Fall fire is more obvious. Everyone can imagine it much easier. So a lot of barriers, nets, different types. So we want to detect these elements, lack of them, and somehow integrate with construction site. Here, I'll show you, sorry, because I tried to turn on the video, but yeah, I tried to find my mouse.
It was there.
Right. It's 21st century.
Let's do results.
Yeah,
Yes.
it was quite important. Okay, so on the first video we have robot ground vehicle which goes through the construction site based on predefined mission and is able to gather the data, image data in both RGB and thermal pictures. Of course, it has some limitations. So the construction site must be relatively clean. We can have many garbage on the floor, so it's some limitation. The drone, it's hard to see right now without video, but based on its path, it's able to maintain and keep a certain distance, fixed distance from elements. So that's important to avoid any obstacles occurring on construction site, because the construction site, comparing to a digital twin of asset management phase, dynamically change its geometry. And how a result looks like. So we have a raw point cloud, which you saw probably today a few times. So first picture at the top shows parts of point cloud and points mapped with BIM elements, so with BIM models. So instead of displaying this point cloud, we can display our BIM model. And second part of this point cloud represent temporary data structure, material storages, and this type of elements which are temporary on our construction site. Okay, we have our data, and somehow we have to link them to make them understandable for our system. So for this purpose, we were using YOLO algorithm to detect different objects. As you see, YOLO algorithm is well-known algorithm for image object detection using images. By saying YOLO, I mean here you look only once, not you live only once. And that data, of course, doesn't contain information about components which are typical for construction site. Barriers, nets, garbage, and many more. So we had to retrain the algorithm and make a fine-tuning of it to add additional labels interesting for us. And in total, we achieved accuracy around 94.6%, so it wasn't the worst. Data structure. We have lots of images, and we want to connect them somehow to understandable and machine-readable data structure. So we invented a risk ontology, which can use a risk zone. Then we have a risk, so this is particular risk, and different levels, so like enums, risk type, and risk-related object. The risk zone was used here to link it with, for example, IFC space. So it was connected with different ontologies. And also, using zone, we could warn employees working in certain zone that there is some danger over there, some risk, and we could pay their attention to make it more careful because it was fixed. Let's try with video one more time. Yeah, because here is too many. Yeah, maybe. Yeah, I will. Sorry. Yeah, maybe like click.
So it's a hyperlink or?
Yeah, it was like insert and then video. So I enable content there. Yeah. Okay, let's try it. Okay. Okay. There's progress. Our digital twin with YouTube works. And now you see the demonstration, thank you, of the application which was developed during the BIMprove project. So in top views, you see users using VR. Left bottom is desktop user, and right bottom are users is camera and laboratory. And here you see virtual walk inspection using the connected point cloud with BIM models, and 3 users performing inspection together. So here there is some issue reported to database with some missing element, some issue with the railing. After reporting such issue, okay, there's railing gap, it shouldn't be there, and we could continue our inspection going on the second floor. And on the second floor, there is obvious that there's some barrier missing over here. So we could draw it, how it should look like on the construction site. Then, of course, apply some BCF for it and continue our work. Okay, the last functionality is waypoint. So we can create a path from one point to another. That path might be converted into trajectory and might be used by, for example, a drone to use trajectory to make autonomous flights from point A to B to make a regular inspection. And of course, there is teleport option. So if we are performing inspection separately, we can teleport all users to one point to make the inspection together and decide about certain location. So I'm not going to touch anything more, I'm afraid, right now. And here you see the construction office. And this is desktop user who switched to phone camera. And okay, he's leaving the building. Wait for it. And now we see our construction site on this other part, other side of the road. So as you see, that was the workflow from gathering data, raw data from construction site, to pre-process them into a useful system, link them with ontologies, and then using by supervising staff. Okay, if you want to have more videos, reports, please visit our website. Thank you for your attention.
Yes, thank you, Wojciech. It was very interesting and technically challenging presentation, to say it like that. At the end, we reached it. as announced in the very beginning, so we have a Slido kind of question and answer gathering place. I can, or we can show again that number a bit later on. So there you can gather the questions that we will have at everything goes well at 4 o'clock. We will have the first panel debate that we invite back all the presenters, and then we will kind of go through those questions that we might have kind of paused in the middle of the presentation. So thank you, Oshek, again, please. Thank you. And then okay, yeah. So and then the next presenter, it will be Rahul, and we will try not to kill the PC. Just let it be.
No.
So I can share my screen.
We're still sharing.
Hello everyone, my name is Rahul Papa. I'm here today presenting the project ASHVIN, in which we have developed ontology called as in platology, so using the name of a plateau, that's why. It's the digital twin ontology suite for the complete life cycle of infrastructure. Something about our ASHVIN project, so it's 14 partners we have across the EU member states. Strong expertise within the construction and engineering management, digital twin technology, IoT, data security, and privacy. For this, coordination is going on through the TU Berlin. This project is working on mostly towards all infrastructure, all life cycle of the infrastructure, but majorly focus on the construction side due to the time limitation of a 3 years period for the project. We do have 10 demonstrators to do from all the life cycle, but 4 or 6 are majorly for the construction side. So the digital twin platform we proposed here is an ASHVIN, which aims to basically achieve our ambition by considering the impact of the decisions that we are going to take in the different phases. The decision made in early design phase is very important, has an impact on what can be later improved during the construction time or even for the maintenance time. Moreover, using the state-of-the-art techniques such as generated design, we can look on not only at generating multiple designs, but also multitude of construction alternatives during the construction, and that is also a possibility of using that. So this construction requires tools that allows managers control the process in near real time. So nothing is real time, so near real time. We have around 10 tools in this project used by project managers in different. So we do have a demonstration, but we will demonstrate also. So what is our motivation for this? Basically, the ontology or the ASHVIN project going on. So its digital solutions are widely used across all AC industry. Now, the digital twins, this is integrated. It's integrate many technologies and methodologies. And systemization concept of these things. The whole point is about using the different methodologies from different industries, specifically from the manufacturing industry or automobile, because digital twin is far ahead in this industry. So understanding from that the concept and to get to this construction industry, which is lacking, and also taking understanding the ontology, how to define and not to reinvent the wheel in this construction industry, but to reuse what is available. So in our research work for the platology, what we do, platology conceptualize the physical and digital asset. Just now before this presentation also talking about digital twin is about physical asset and a digital asset. So that's the whole point is about to conceptualize it and infrastructure through the entire life cycle. Therefore, we call this name as also, as you can see on the screen, DES DT, CON DT or TT, basically it's design, digital twin, construction and operation digital twin. Most important part here, it comes for the data. the data resource that's the fuel of every digital twin. It's not only digital twin, also whenever we have to do any analysis, we need data from different sources. The main sub-dimension in the proposed framework are the data sources to obtain the data from. The data has to be categorized, they relate to, and the subclasses, data format or input method, show the type of data format, unstructured, structured, interpreted. So as we mentioned about different type of databases, relational database, graph database. So there also in these databases, first of all, we collect the data via IoT sensors. That's an unstructured data, then we structure it for later use for different purposes. So data management, that comes for the data management for the various processes associated with the digital twin. So then we talk about in the process of construction digital twin, basically built environment. Built environment class conceptualize basic functional parameters, parts of the built environment existing physically for a construction. So when we are currently working on the for taking the BIM metadata into digital twin, still many things are missing. For example, IoT sensors are missing from the BIM files. Some scanning methods are missing from the BIM files. At what step what we have to do when we go for a work database, when we divide the structure of the complete processes. So those things has to be added. So we have to understand, we are understanding in this project what are those things and adding into the steps of the built environment to collect. And this is basically, it is based on IEC 81346 series of standards. So there are standards already there. We are using one of our partner standards. They are working possibly to see if the digital twin has standards all available, because BIM and digital twin standards are not similar. They can be different, they can be similar. So this is what the work in progress to see if we have to go for a new standard. We will not develop any new standard in this project. We will just probably propose it to the commission. Then about other processes. So the processes class essentially represents process requires to define the workflow of construction centered on digital twins basically. The figure depicts here different process existing. So different process, we have lean planning, site monitoring, construction simulations, quality control. All these are different processes. All these processes we have to understand, and we have to go very step by step in a lean way, basically like a critical path method in the manufacturing industry we used to do. So that's the critical path method has to be applied in this process to divide each and every step to understand and integrate into a ontology. So if I go deep into side of the site monitoring, for example, to support a digital twin, a sensor construction site is necessary, and it can be done through site monitoring. It conceptualizes dimension of the process, site monitoring through various monitoring methods. Site monitoring can be done via camera, LiDAR camera. One has been shown, other video was not there, but that was basically using a robot to scan the area. This is also in our project, one of our partner, NCC from Sweden, we also use the robot and put a LiDAR camera on the top to monitor the construction site. Currently, it is not possible to do this thing in real time, but we are work is in progress to make it possible in real time. The risk management. So the ontology of the risk, which has also been provided. So risk management, this is very important for aims to minimize the chance of structural failure. This ontology is based on one of the ASHVIN demo case we have done in the query wall. Basically, it's from the Rotterdam port, which has some sensors installed. There is representation in ontology of possible design methods and design conditions which need to satisfy to analyze the risk. Not only the sensors, we have a huge amount of data from this specific site, and to analyze this data and with the help of real-time data, then to predict what the possible risk is. So this specific risk management to add inside of the ontology and to digital twin part is very much required for the future maintenance purpose also for the renewal or any other infrastructure. So what are the outcomes we are having here? It generates through digital twin application aimed to enable productivity, resource efficient and safe construction, which are essentially basically our desired KPIs of the ASHVIN project. Each outcome, like whether it's productivity, efficiency, safety, and cost, has performance indicators identified for planning and controlling construction activities. Each subclass of the outcomes has PI, which contributes to its implementation. So we are not only specified for KPIs to go for, but also for performance indicators to understand each and every cases here that, okay, how to exactly to increase the productivity, how we are going, just not by showing that, okay, this is the result of the construction site data. We have to show this exactly how it is increasing the productivity or increasing the efficiency. So this is the goal for, so that this will be the direct effect of on a practical way in a construction site, project manager can get a benefit out of it. Otherwise, it's just a theory. So the conclusion here is we did use the existing standards, ISO 12006 and IEC 81346. We integrate into existing ontologies. So we are not developing any new ontology. We are just collecting different ontologies or different sector and make it combined in the ASHVIN project. And the development of ASHVIN digital twin platform and its toolkits through API vocabularies. So all the toolkits, what the different partners in the project are developing, they are based on microservice architecture for the very reason for a plug and play to any construction site to use it. Future work for this specific ontology is that we will be developing a web visualization of the ontology, very much similar to the graph database. Validation with more ASHVIN projects. So we did validate for some of the, not all of the STEM. So we have to validate this and then populate and test in different scenarios. So that's just for the case of actually acknowledgement of a project that it's from the ASHVIN project, which we have been funded by the European Commission. Thank you very much.
Good afternoon, everyone. My name is Raúl García Castro, and I'm going to present a bit the work that we are doing in the COGITO project with ontologies. Okay, I will also try to be a bit fast just to catch up with the schedule. So I suppose that you have seen this before also, but in COGITO, our goal by developing the digital twin platform is to try to have this virtual representation of a construction site, okay? And for that, we are mixing, let's say, what we call as planned data, okay? So the data about the geometry, the IFC files, the budget, processes, activities, resources, and so on. We are trying to put it together with reality capture tools, okay? IoT data and visual data, okay? So we have the digital twin platform, and the goal here is to, through the link data standards, to try to support these use cases about safety, visual and geometric quality control, workflow planning and monitoring, and also having a dashboard for visualization, okay, that can be used. So here, as you can imagine, the main requirement for the digital twin platform, well, one of the main requirements is to be able to support semantic interoperability. Okay? We have like two views of the platform, depending on in which phase we are. We take into account the planning phase of the project and the construction phase. Okay, and here between all these heterogeneous components, what we need is to enable seamless data exchange, okay, between all these components. Okay, they all have different protocols, follow different formats, different schemas of the data. Here in COGITO, our approach has been to homogenize everything, okay, using a common data model, a common ontology, okay, that you can imagine all the benefits that it provides us, no, having this common vocabulary in the project between the people and the machines, that also, on the other hand, is grounded on some formal semantics. No? So this is very important, that every component has the same interpretation and reasoning over the information that we have, okay? and that also enables us, for example, to check for consistency in the data. As I mentioned before, we rely in the digital twin platform on the semantic web standards for supporting this interoperability. We follow the usual semantic web stack, RDF, OWL, Sparkle, and we use Shackle for validation. And also one thing that we do is to follow the Web of Things approach, okay, to support the discovery and access of data into the digital twin platform. This is one figure that a bit summarizes the digital twin platform with the different layers for authentication, data ingestion, persistence, data management, messaging, and post-processing. No? And here the idea is what I mentioned before. We have these different data sources, okay, that we have. Each of them needs to be translated into a common knowledge graph where we put everything together, okay, and link everything as linked data. So for that, here we have in green the ETL tools, no, the tools that are in charge for each of the different types of data that are coming to transform them and include them into the knowledge graph, okay. And then we have also a set of tools for model checking, okay, for validation from different perspectives, from RDF, MMD, and so on. And then we have some things like the IFC optimizer and other internal things. No? But the idea is that we try to convert everything into this single knowledge graph, okay, that can be used. But for that, of course, we need to know how to represent this information, okay? And here is where the ontology comes. So in the project, we are following the link open terms methodology, the LOT methodology, that follows a cyclic approach, okay, in different sprints, and we perform the expected activities in any engineering task, okay? We specify requirements, make some implementation. We publish the ontology, so this is something, we put the ontology online, so it is accessible inside and outside the consortium. And we have some mechanisms in order to get feedback so we can improve the ontology while it is being used, okay? So going a bit through all these phases for gathering the requirements, the way in which we are working in COGITO is starting from the sequence diagrams of the different use cases. We identify which files are coming and going from the digital twin platform, okay? And here we have the domains of interest, okay? And we can take into account here that we are covering, let's say in general, the part related to the product and the process, okay? Related to the product, we have all the things related to the construction site, the buildings, and so on. Related to the process, the tasks, the process itself, the workflows, and so on. We also cover in our ontologies all these things related to the reality capture, okay, the visual reality capture, the Internet of Things reality capture, the simulation, and of course, we cover these things that are devoted to the different use cases that we have, okay, for quality control, safety, and the management of workflows. In order to make the implementation, we first make a conceptualization using the chalk tool, okay, that follows the chalk notation. So this allows us to make diagrams like the one that appears here. And we use these diagrams in order to validate the conceptualizations, okay? Over time, we discuss this with end users and we evolve the diagrams. And once we have an agreed version of the diagram, what we do is to make an implementation. As chalk allows exporting into OWL, and then we open the file with Protege, for example, and make a final changes in the implementation. So in this moment, what we have by the end of this month, well, right now, so right now in the COGITO project, in October, we finished the second year, and we are finishing we are currently finishing the development of the platform, of the ontologies. So this is something that is continuously changing these last months. Currently, what we have, and that you can see an overview in the picture, is different ontology modules to cover what is the facilities, the construction site, the processes, also the resources, okay, the part of the workflow and the part of the resources, and things related to the use cases, a module for quality and another for safety. Okay? And in the development of these ontologies, we have reused usual suspects for the people that are working in this, some ontologies from the W3C, some from Etsy, and other well-known ontologies for representing things like building elements or things like that. So all this development, when we talk about the publication of the ontology, it involves publishing not only the old file, but all the artifacts that are related to the ontology development process. Okay, so if you go to this URL in COGITO IoT link data.s, you can see the COGITO ontology portal where you can download all the artifacts that are related to the development, from the documentation of the ontology to the requirements, figures, tests. We have you can check all the versions of the ontology. They are stored in GitHub repositories. We have issue trackers for them and so on. Okay, so we centralize everything there, and they are ontologies that are openly available. And then at the end, so the goal is to have this knowledge graph that includes and links all the information that is related to the digital twin of the construction process. Okay, so this allows, for example, well, in the left you can see like a depiction of the knowledge graph, but in the right you can see that, for example, in the top we have an IFC model, a BIM model, and the knowledge graph allows us to query this digital twin platform and tell, for example, tell me about the columns that are related to the task that right now this worker has to do. Okay, we can make this query, and then we have the subset of relevance of this of our digital twin, okay, that can be used in the different tools. So here you have a bit detailed example where we can see, for example, how everything is linked from the part related to the construction, to the process, and to the resources. And it tells me that in the model, for every element, which are the tasks that affect the element and which workers are working on that. Okay? And then we have the links from one resource to the others. So we can see the information as a whole. Okay, but if we ask only for a task, we only have the links. We also have the links to the other relevant entities in the digital twin. And that's it. So right now, as I mentioned, we are currently actively working in the development. So they are not, we don't have a stable version of the ontologies yet. Okay. In any case, even if our work is right now being like internal to the consortium, everything that we have is open. And if you want to see something or would like to see something added to the ontologies or whatever, just tell us or open an issue in the issue tracker. So we are open to that. And then one of the next steps involves also the validation of the knowledge graph and all of the different steps of the process for generating it. And that's it. Thank you very much. And I'll be open to any questions here in the chat, in a Slido, wherever. So I'm going to stop sharing.
Good afternoon, everyone. I hope you can hear me and see my slides. Unless I don't hear, I should assume that that's the case. I'm Jonas. I'm here to represent the project. And well, the lengthy, but to do the of the project and on the data modeling part. Firstly, so based on digital which COGITO immediately under. And finally, just talk project and since the or I'll try to switch off the camera. Just okay. So I'll continue in this way and hope that the sound is getting better. So to dive right into the topic, the BIM2Twin project is kind of like focusing on a digital twin of the construction phase, as also the other projects that we that are presented here today. Our goal is to gain situational awareness of kind of everything that is going on the construction site, and we really try to focus on the processes, try to capture when they start, when they end, if there are any issues, and try to compare them between like what was planned and then what was actually executed. And we are kind of implementing a full cycle model of planning and control, which you can imagine something like what is shown here on the right-hand side. So we have this physical twin on the right-hand side, which basically is the construction site. We're going to monitor this construction site with laser scans, sensors, images, and store this information in the digital twin platform. And then we have basically two kind of feedback loops. One is more like focused on real-time feedback, where we try to immediately detect any issues and problems. And then on the other side, we have like a more long-term feedback, where we try to improve design and planning based on, well, long monitoring processes and maybe even things that we learned from other digital twins, other construction sites that were monitored before. The way we structured our data in this BIM2Twin project is that we kind of split it into three parts. So we have here this pyramid of data, information, and knowledge. So basically the data part is like the raw data coming from the construction site, which could be, for example, laser scans, images, sensor data. And then we're going to process this data and kind of like end up with the information part. An example here could be that you take the point cloud, you kind of analyze it and see, okay, a certain building element just has been built. And then you kind of like store this information in this information part. And then finally, we have this knowledge layer, where we have more aggregated information, some different sorts of KPIs that help construction managers and other people to quickly get an understanding of what is going on their construction site and everything is going fine or not. And for these different layers, we have, or currently are developing different ontologies. We have like the BIM2Twin data ontology, which is basically kind of a lookup graph. We store metadata about the different types of information that we capture in construction site. Since, well, it doesn't really make sense to store a point cloud in RDF graph, for example. So we have like dedicated storages for this raw data. Then we have the BIM2Twin core and the core extension, which is like the kind of main part of our data model. Here we store like this main monitoring information and have like kind of information about the project status and project intent. So basically information about how things are planned, but then also how they're actually executed. And finally, we have this KPI ontology, where we try to formalize these different types of KPIs that are then displayed to the user in the dashboard. So I'll go a bit more detail into the different ontologies that I just mentioned, but try to keep it short to not overextend the time. So the data ontology, as I mentioned, is kind of like has this catalog function. So basically, we have different digital twin services. So these are basically different applications that have more domain-specific things that they would like to achieve. Then we have our BIM database, kind of like an RDF graph where we store all of the information, except for the raw data. This has like a dedicated storage, and here in this data graph, we kind of like point to the different places where the different digital twin services can find the raw data to make like the queries here more performant and faster. And to large parts, we're reusing here the SOSA and SSN ontology, since they're describing very well the kind of capturing of different data, timestamps, and so on. Then the second part is the BIM core ontology. Here we decided to kind of separate everything into these two sides. We have project intent and project status. So intent being the planning, and that status how it is actually executed. And you can imagine these two as kind of containers. To some parts, they do use classes. It's like clear differences that I'm going to talk about in think. Separately, the so that we have a connection between element as it is to as it is executed in the project, and so that we can make this direct comparison, which is the whole point of having these two sides. Okay, I hope that you still can understand. I just continue since I'm not sure what else to do. Well, the common part between those two sites is like the building structure. Here we are using the building topology ontology. And since we don't expect large changes, for example, we expect that we have the same amount of stories, the same amount of buildings, and things like that. Just going a bit more into detail what this ontology contains. So we have like a part that is dedicated to construction processes, which is like, I'd say the most important part here. We have a part about the process preconditions. So these are like the preconditions that need to be met for a certain process to be able to start. So our goal is to kind of like dynamically reschedule processes in case there are any problems. So we always need to know which kind of processes are kind of ready to be started, and this can be modeled, or we are modeling this with these preconditions. Then on the top, we have different types of resources like construction workers, equipment, material, and so on. We have a part about different working zones, and finally you have the building structure, which is basically coming from the bot ontology. Then just quickly talking about the difference between like this project status and intent ontologies that I mentioned before. So so the main difference between those two sides lies in the different attributes, not so much in different classes. The reason for that is most importantly the different levels of granularity between the planning and the execution, because one, like in the beginning, the kind of construction schedule always is rather rough, and for example, you don't have information about what a certain worker is going to be doing at a certain point in time. But then again, if you try to from the other side try to rebuild what was actually done in construction site, you really have to start at location of certain workers, if they're active or not, and things like that. And these are kind of like the main differences between those two sites. Then we have this core ontology extension. Here we kind of have different domain-specific classes. Well, basically, these are the different work packages in the BIMprove project. We have one that is considering the worker safety. We have one that is doing simulations and trying to come up with alternative schedules. We are focusing on equipment optimization, and also quality improvement of volumetric surface elements. And yes, because of like reusability purposes, we separated them into different groups, and this also helps us to validate them one by one, not all at the same time. And then finally, the KPI, and this is mainly the different well analysis of like reusing for the units and summarize, so still kind of like adding of produce and multiple participation. Well, and do what we planned is can you hear me? Can you? Okay, so this was hello, can you hear me? Okay, yeah, so, not